Hello dear students, welcome to my YouTube channel Jeet Academy. In this particular video, I'll be talking about October-November paper 1 and the variant is 970912. Alright, so let's start. So here the first question is from transformation of functions. So let me read it. The diagram shows the curve with equation y equal to a sine bx plus c for x 0 to 2 pi where a, b, c are positive constants and state the values of a, b and c. So they're asking us to find the values of a, b, and c, and the graph is given to us over here. So this is basically a sine function, right? So how does a sine function look like? So our reference graph is this, y equal to sine x. All right. Now, two things I should know about the sine function. One is the period of sine function is 2 pi. That means it repeats itself after 2 pi interval. Also, I know the graph from 0 to 2 pi, it is one cycle like this, isn't it? 0 to 2 pi. That means there is only one wave. Now, similarly, this particular graph which is given to us, so if I compare it with the reference graph of y equal to sine x, what do I see is this is one complete cycle and it starts from 3 ends at 3 from 0 to pi, isn't it? So from 0 to 2 pi, if there is one wave, we say sine x, isn't it? So what will be the period of this? And then there is another wave from pi to 2 pi, isn't it? So basically there are two waves from 0 to 2 pi. So what will be the period? Period will be 2. And therefore, b value is equal to 2. Got it? So sine bx. If there are three waves, then sine 3x. If there are four waves from 0 to 2 pi, right? Period is nothing but the interval after which this particular function repeats itself. Okay. Now what is the amplitude? I see here the reference graph is from 0 to 2 pi and it starts from 0, isn't it? So if it starts from 0, here in this particular case, the graph which is given to us is starting from 3, right? So at 3, I'll draw the reference axis. This is my new x-axis. So the x-axis has shifted 3 units upwards, isn't it? So from this x-axis, new x-axis, what is this displacement of the maximum crest? So it is 3 and here it is 7. So what is the amplitude? 4. And downwards also you could check. This is also 4. Right. So here the multiplication of a with sine x is called as the amplitude. What is this a called as? This is called as an amplitude. The maximum displacement of this wave from the mean position. Okay. So that's 4. And therefore I get a equal to 4. Okay. Now how do I compute the value of c? In order to find value of c, you just take any one point, right? So how do I do that? To get the value of c, take a point from the graph. So the simple thing is to take 0. X equal to 0, what is y? Y is equal to 3, isn't it? So from the graph, I can observe that when x is 0, y is equal to 3. And therefore, y equal to a value is 4 sine 2x plus c. When x is 0, we get 2 times 0 plus c. Sine 0, we know that it is 0. So 4 times 0 becomes 0 plus c, and henceforth we get the value of c as 3. All right. So we got the value of c as 3. And therefore our final answer, a is equal to 4, b is equal to 2, and c is equal to 3. I hope you understood the concept. Okay. Now, coming on to the next one. For these values of a, b, c, determine the number of solutions in the interval 0 to 2 pi for each of the following equations. So we have, gotten the values of a, b, and c, and we have found what is this. Now, this is equal to 7 minus x. Now think, can I take the RHS to be y? And it's a straight line. So y equal to 7 minus x. Okay, so I just need to draw this. I need to draw this line 7 minus x on the graph which is given to us over here. Okay, so let me quickly erase this. And now I need to draw the graph of 7 minus x. Okay, now important thing is how do you draw the graph of 7 minus x? So I need particular points. So important catch over here is how to get a rough sense of it. Okay, because it is just for 1 mark. So I just need to get a rough sense of it. So how will I get? check here. What are the x values? The minimum value of x for which the graph has been drawn and the maximum value of it. Okay, so when I plug in 0, so what is y? Y is 7 minus 0, which is 7. So this point, getting it? So this point is 0, 7. Now, what is the maximum point? Now, assume that 2 pi value is 3.14. So 2 pi would be close to what? 6, 6.28 actually, because if I take to 2 decimal place, pi value is how much? Pi is 3.14. So basically, y will be how much? So 7 minus 2 pi, roughly it will give me 1. It will be actually lesser than 1. So where it will be? This point is 1, so somewhere here. Getting it? So at this point, now quickly join this. Right? So that's my line. Y is equal to 7 minus x. Now I need to find the number of solutions. So just check where it is crossing the sin x graph. 1, 2, 3, 4, and 5. Got it? So 1, 2, 3. This is what we know. Point of intersection gives us the solution. So how many solutions are there? There are total 5 solutions. I hope it makes sense. Now, similarly, we need to solve the second bit, which is now a sin bx plus c equal to 2 pi x minus 1. So how do I get this line? This is also a line, right? So I can interpret this as y equal to 2 pi x minus 1. Got it? So again, I'll plot it. I'll get a rough sense of it. So let me quickly erase this part. And we need to draw 2 pi times x minus 1. Okay, so let me quickly erase this. Now see here, we have y equal to 2 pi x minus 1. Got it? Now when I plug in x is equal to 0, right? These are the endpoints 0 and 2 pi. I need to check how this line goes. So when x is equal to 0, I get y is equal to 2 pi times 0 minus 1, which is negative 2 pi. And pi is roughly 3 point something, so 2 times 3. So approximate value will be negative 6 something, right? So where will be negative 6? If I extrapolate this graph, let's say this is. Okay, I just need to get a rough sense of it. So this point is 0, negative 6. I hope you are getting this. Okay, now since the gradient of this line 2 pi is positive, so it will be a rising upwards graph, isn't it? Now at 2 pi. So when x is equal to 2 pi, how much is y, right? So 2 pi times 2 pi minus 1. So 2 pi is approximately 6. 2 pi I can approximate as 6 minus 1. So I roughly get 6 minus 1 is 5. 5 times 6 is 30. So approximately y will be equal to 30. Now you only see where 30 will be. So if I extrapolate this graph, so 30 will be somewhere here, isn't it? So when x is 2 pi, at this point, the 30 will be somewhere here. Got it? Very, very large value. Somewhere here, basically. Okay. So if I join that, I'll basically see it goes like this. Right? Now I need to find where it will cross. So this is the only point where it will cross it. I hope it makes sense. Okay. So this is how you can have a rough sense of it and check where the graph is crossing it. So this is the only point of intersection. So our solution is basically over here as 1. Okay. How many solutions did we get here? 1 solution only from the graph. Okay. Fine. Now moving on to the next question. Let's read this. The first term of an arithmetic progression is negative 20, right? And the common difference is 5. You have to find the sum of the first 20 terms of the progression. So let's try to do this. We are given with an AP whose first term is basically negative 20. Common difference is 5 and we have n is equal to 20. This is what is given to us. Now using MF19, you can check the formula for sum of first n terms of an AP. So sum Sn is given by n by 2 times 2a plus n minus 1 times t. And here n is 20. So I'll just plug in 20 over 2. A is negative 20. N is 19 times t. Okay. So S20 becomes 10, negative 40, plus 20 times y is 100, minus y is 95. So 95 minus 40 is 55 times 10 is 550. So 550 is the solution. Okay. So you have to refer the formula sheet MF19 and that is your answer. Okay. Perfect. Now moving on to the next concept. Here it is given that the sum of the first 2k terms is 10 times the sum of the first k terms. Find the value of k. Okay, so let's interpret this. I can say the sum of first 2k terms would be is 2k, right? So here n value is basically n is equal to 2k, and here n is equal to k. Okay, so apply the same formula. N is 2k over 2. A still remains the same, so that's negative 20, right? Plus n minus 1. N is 2k, so 2k minus 1 times d is 5. Okay, and we have equal to, this is 10 times the sum, so 10 times the sum of is k. Okay, so I'm rewriting this over here. 2k by 2, I get negative 40 plus 2k minus 1, all right, times 5 equal to 10 times the value of sk. So sk would be what? K is equal to n. Here also 2 times a, which is 20, plus n minus 1, so n is k, times d is 5. All right. So I can quickly see here, 2 and 2 can be cancelled out. Okay, now simplify everything. This negative 40, 2k times 5 is positive 10k. Negative 1 times 5 is negative 5. And then 10 is outside, so I can take it as 5k, right? 2 times 10 is, 5 is 10. So let me rewrite this. So I get basically 5k, negative 40 plus 5k minus 5. Quickly rearranging this. Now we can cancel out k and k also from here. All right, because I just need a value of k. So, or if you don't want to cancel, let's take it as, in terms of quadratic also. So let's check that, because you never know, right, which value you have canceled out. So don't cancel. Let's check how much we are getting here. So I get negative 45 plus 10k, whole thing multiplied by k, equal to 5k negative 45 multiplied by 5k. So if I open this, I'll basically get 10k squared minus 45k equal to 25k squared minus 45 times 5. So 45 times 5 would be, I'll basically get 25 to 225. So that's 225k. Okay, now shifting everything to right hand side, I'll get 25k squared minus 10k squared minus 225k plus 45k equal to 0. Now 25 minus 10 gives you 15k squared, and then minus 225 plus 45. So that gives you negative 180k equal to 0. Now I can take 5k common, and therefore I'll get 3k minus, so 5 threes are is 15, I get 30, so 36k equal to 0. All right, and therefore from here I get k equal to 0, and I get 3k equal to, this is just 36. Okay, equal to 36, and therefore from here I get 36 over 3, which turns out to be 12. Therefore k equal to 12. Okay, and we got k equal to 0. So let's check what is the condition for k. Okay, now the sum of first k terms, right? Now use common sense and guess, can k be equal to 0? Terms cannot be equal to 0, right? And therefore k equal to 12. We disregard this because the number of terms starts from 1, right? So k equal to 12 is the correct answer. Okay, moving on to the next one. Let's see this belongs to which category. The equation of a curve is y equal to 2x squared minus 3. 2 points, so let me highlight this. A and B with x coordinates 2 and 2 plus h. So there are 2 points A and B whose x coordinates are given to us as 2 and 2 plus h respectively, which lie on the curve. We need to find and simplify an expression for the gradient of the chord AB in terms of h. All right, so now equation of this is given to us, right? Now I need to find basically the gradient of the chord AB. So I can write the formula as y2 minus y1 over x2 minus x1. So clearly I can say here that for A, x value was given, and for B, x value was given. right? So if I assume x1 is 2, so I need to find the value of y1 and I need to find the value of y2. Okay, so for a, x is equal to 2. So how do I get y? Y is this, right? Because a and b, they are contained in the curve. So how much is y? We get 2 times 2 squared minus 3, which turns out to be 8 minus 3 is equal to 5. So we get the coordinates of a as 2 comma 5. And let's quickly do this for y as well. So it's 2 plus h. Therefore, y would be 2 times, you just plug in the values of x. Okay, 2 plus h whole squared minus 3. So this turns out to be, okay, for time being, let it be as it is. All right. So we get b as 2 plus h, comma, 2 times 2 plus h whole squared. Let's simplify this later. So we got this. Now I need to simplify. M of AB is, let's say this is y2, this is x2, this is x1, and this is y1. So what is the gradient formula? 2 times 2 plus h whole squared minus 3. So this is y2 minus y1, which is 5, over x2 minus x1. So 2 plus h minus 2. Right. So 2 and 2 cancels out. We get 2 times 2 plus h whole squared minus 8 over h. Right. So MAB. Now if I expand this, I basically get 2 plus h whole square is 4. 2 square is 4 plus 4h plus h squared minus 8 over h. Okay. So now let me extend this over here a little bit. And now I get m of AB is equal to, simplify this, 2 times 4 is 8 plus 8h plus 2h squared. Take this 2 inside and multiply with all the terms, minus 8 over h. So positive 8 and negative 8 cancels out. We get the gradient of the chord as 8h plus 2h squared over h. Now I can cancel out the common h over here. So I basically get h cancels out plus 2h. So this is the gradient of the chord AB. Okay. So now let me put this over here. AB is equal to 8 plus 2h. And this is what we got the gradient of the chord as. And let me quickly erase this remaining working over here so that we can do the working of the next part. Now, B part is, they are saying explain how the gradient of the curve at point A can be deduced from the answer to part A and state the value of the gradient, right? So we basically need to find the gradient value at A and using the answer to part A. That is what they have mentioned over here, right? Now, how do we usually find the gradient? Okay, so how do you basically calculate the gradient? The curve is given at point A, x coordinate is given. So what you guys will do, most of the students, they'll find dy by dx. So if you differentiate this function 2x squared minus 3, 2x squared minus 3, derivative will be 4x. And then at A, dy by dx at A, x coordinate is how much? 2. So this will become 4 times 2, which is equal to 8. And you guys will say, okay, 8 is the answer. But they're not asking this process. Okay, if you're doing this, don't do this, you will get 0. Okay, marks will not be rewarded for this approach because they're asking you have to use the answer to A. Okay, so let's try to analyze what is given to us. There are 2 points A and B with the x coordinates, and it's a parabola, right? So let's try to get the sense of it. 2x squared minus 3 is a parabola which is opening upwards, something sort of this. Okay, that's a parabola. And consider 2 points, A and B over here. Right, what is the x coordinate of A? 2. What is the y coordinate? 5. X coordinate is 2 plus h and y coordinate is 2 times 2 plus h whole square minus 3. Right. Now, if you join this is a chord, isn't it? So dy by dx basically gives you what? Tangent, right? It gives you a tangent at point A, right? So when I will get, this is basically called as a secant. This is called as a secant. Secant is a line that crosses a curve at 2 points. Okay, so this secant will become a tangent When can I say when h is approaching 0? When you approach this h tending towards 0, wouldn't b will merge with a? Yes. So that is what they are checking, the limit concept. Okay. So the secant will become a tangent because the tangent, the gradient of the curve at this particular point A is nothing but the tangent, the slope of the tangent as well. Right. So the concept I need to use is x is tending, h is tending towards 0. So I already know what is the gradient of the chord. The chord becomes a tangent. Right. This AB was a chord actually, and now it becomes a tangent when h is approaching 0. So therefore, it is 8 plus 2h, isn't it? The gradient which we have found in part A, this formula I have to use. And therefore, when h is approaching 0, can I simply say 2 times 0? And therefore, the gradient of the chord, which becomes a tangent, will be equal to 8. Okay, so you have to apply this concept and not the derivative, finding the derivative of the function. I hope this explanation is clear to you. And this is the actual meaning of the gradient, finding the gradient, right? From secant, it becomes tangent when h is approaching 0. Because at a point we have to find, right? dy by dx is an instantaneous change. So when a and b, think of it as an interval, when it will become an instant, when b is very, very close to a. Right, so a is like 1 second and b is 2 seconds. So 1 second is a huge margin, right? It is not an instant. Instant would be, let's suppose if a is 1 second, so after a point second, right? A millisecond. So 1.001. Okay, so how close it will be when B is very, very close to A. Or you can say, but it is not equal to A. It is tending towards A. Okay, so this is what we have to do here. I hope you understood this concept. Now, moving on to the next one. So it is from sequence and series. Okay, binomial. So let's read this. Find the term independent of x in the expansion of the following, and we are given with this expression. So now let's try to, figure out what is the general term, right? So general term is nothing but NCR, a to the power n minus r, b to the power r in the expansion of binomial expansion. So this is how the general term is given. Now n value is 6, a is x, and b is 3 over x squared, right? So I'll plug in 6 r, a is x, b is 3 over x squared, right? So here I should write 6 minus r, and here I should write r. Okay, now simplify this. 6cr, x to the power 6 minus r, 3 to the power r over x to the power 2r. I hope you get this because x square is there. If I have x to the power m, whole thing to the power n, this is called as x to the power mn. Power to the power gets multiplied. Now this term is what? I'm writing it down over here. This term, when bases are same, what happens to the exponent? The exponent gets, when bases are same in division, the exponent gets subtracted. So x to the power 6 minus r minus 2r. So this basically becomes x to the power 6 minus 3r. Right. Now the term independent of x, that means when this x will go, when the power is 0, when this becomes equal to 0. Right. Therefore, 6 minus 3r should be equal to 0, or 6 equal to 3r, or r is equal to 2. Got it? So now all you need to do is just plug in r equal to 2, right, in this equation. So we get 6c2 x to the power 4, and here we get 3. So this is basically the shortcut. You could have also expanded by 6c0, 6c1, and so on and so forth. All right. So if you find a difficulty in, doing it, expanding all the terms not necessary, you can approach this formula because they're saying the term independent of x, right? So the power of x should be equal to 0. So I've equated the exponent of x to 0. So we get therefore r is equal to 2. So this will become x squared whole squared. So 6c2 is basically 15, and x power 4 and x square and square cancels out to, so you get 3 squared. So 15 times 9 is basically 135, right? So that's your answer, 135. Now coming on to the next one. Here they are saying b part. The expansion of this is basically multiplied by this term 4x cubed minus 5, and we need to find the term independent of x. So now here for time being, I need to expand this in order to get, see, try to visualize this. When we will get term independent of x, when you open this 4x cubed term multiplied by 1 by x cubed term, okay, in the expansion of this, and negative 5 multiplied by a constant term in the expansion of x plus 3 over x squared to the power 6, right? So we will get two terms independent of x. The constant term in the expansion of x plus 3 over x squared to the power 6 multiplied by 5, because 5 is a constant. Also 4x cubed multiplied by the term which has the power x cubed. Okay, so I'll just expand this. I'll start with 6c0. Okay, so x to the power 6, 3 over x squared plus 6c1. Okay, x to the power 5, 3 over x squared to the power 1 plus 6c2, x to the power 4, 3 over x squared to the power 2. Okay, so where do we get 1 over x? Okay, let me do one more term. 6c3 x cube 3 over x squared whole thing to the power 3. Okay, so I need to open till 3. Right, so now we have 4x cubed minus 5. So which term is independent of x? Now I can check here. I see that in this expansion, x to the power 6 over x square, right? So this will give you x power 4. So I don't need this one. So this rules out. Now here x power 5 over x power 2. So this will give me x to the power. So this was basically 0. So this gives me x power 6 actually. Now this gives you x to the power 3. Right? I need the term 1 over x cube. So 1 over x cube, here I get 0 term. 6c2, which we have already seen in the previous part. Right? 6c2 was the term independent of x. So that is a constant term, 6c2. I need this one. And 6c3, this also gives me x to the power 3 and x square whole thing to the power 3. So this gives you x cube over x to the power 6, right? X square to the power 3 is x power 6, and this gives you 1 over x to the power 3. That means what I get is 6c2 x to the power 4, 3 square over x power 4 plus 6c3 x cube times 3 cube over x to the power 6, right? These two terms I got. Now if I multiply these terms, 4x cubed multiplied by 6c3, and then so this cancels out with cube. So this comes with 3 cube times 1 over x cube, and then minus 5 multiplied by 6c2 term multiplied by 6c2 multiplied by 3 squared. Okay, because x power 4 and x power 4 will cancel out from here. Now x cube and x cube cancels out. 3 cube is 27 times 4 times 6c3 minus 5 times 6c2. We already know it's 15, and this is 9. So this was 135 times 5, and I need to compute quickly this one. So that turns out to be 6c3. Okay, so 6c3 gives you 6 factorial over 30, 120 over 6, which is 20. So this turns out to be 24, 27. So 80 times 27 minus 135 times 5. So if you do this using the calculator, final answer is 1485, and that's your answer. Okay, so the basic concept is you have to think like this. You don't have to expand all the terms, just see which term over here, because constant multiplied by the constant, isn't it? And then x cube multiplied by the 1 by x cube term, that will give you the terms independent of x, isn't it? So that's your answer. Now, moving on to the next one, fifth question. Let's quickly read this. The function f is defined by f of x equal to 2x plus 1, all right, over 2x minus 1 for x lesser than 1 by 2. So this is the function which is given to us, and this is the domain which is given to us. So we have to find the value of f of -1. So one thing which I clearly know from here is this is the domain. Okay, so f of -1, that means in place of x, just plug in -1. So -1 plus 1 over 2 times -1, -1. So that becomes -2 plus 1 over -3. So that's -1 over -3. Negative sign and negative gets cancelled out. And therefore, finally, we get f of -1 as equal to +1 over 3. So that is the answer for the first one. Okay. Now coming on to the next question, it says the diagram shows the graph of y equal to f of x. Sketch the graph of inverse function, right? Y equal to f inverse of x. On this diagram, show any relevant mirror line. So we are given with the graph of y equal to f of x. All right. So let's analyze what do we mean by inverse, right? Let's understand the concept first. So I know that the domain of f of x will become the range of f inverse of x, right? That means the y range is what? Y value. So can I simply say my mirror line would be y equal to x, isn't it? Then only inverse will exist. The input will become the output and the output will become the input. So whenever they ask you to draw the graph of inverse function, the very first thing is blindly draw the y equal to x line, which will be crossing this way. The origin, and please pardon because I won't be able to draw the straight line now like this. Okay, so this is the line y equal to x. So inverse always exists with the mirror line y equal to x. Okay, because y is called as the range and x is called as the domain. So domain will become range and range will become domain. Now what I see from here is x is lesser than 1 by 2. So this is the domain. So now my new function f inverse, let me write it down. What will be the range of f inverse? The range would be lesser than 1 by 2 because the domain of f of x was lesser than 1 by 2. So the range will be lesser than 1 by 2. I hope you are understanding this concept. Okay, so now I know that this is y equal to 1. Okay, this is y equal to 1. So where will be y equal to 1 by 2? So 1 by 2 will be somewhere here. Okay, this is y equal to 1 by 2. Getting it? So now let me erase this 1. So y is equal to 1 by 2 is this point. All right. So I need to draw a line over here, which will act as an asymptote because it will not touch because range is lesser than 1 by 2. It is not equal to 1 by 2. Okay, so this sense I got. Now, what is the next thing? Range. I need to find the domain of f inverse of x. What will be the domain? Right? So just by looking at this, what is the range I can see of f of x from the graph? So range I can see it is lesser than 1. Right? It is lesser than 1. So range of f of x from graph, what I can interpret is this is 1 value over here. And the graph of f of x is entirely below 1 and it is going up to negative infinity, isn't it? So ranges of f of x lesser than 1. So what will be the domain of f inverse of x? Domain will be lesser than 1. Are you getting it? So now let me draw a line. Okay, let me use a green color. So now I'm going to draw the function, right? So range is lesser than 1 by 2 and it goes up to negative, right? And domain is x lesser than 1. So let me mark the domain as well. So this is the domain, x is equal to 1. Okay, so here x is equal to 1. So domain is lesser than 1. So this is the line. X is equal to 1 is here and I have y is equal to 1 by 2. Okay, so smaller than this. So now I'll use a different color. Okay, let me use this color. So how to draw lesser than this and it will cross at 45, right? At this point, like this. And how it will go? Follow the same instruction. So it will cross here like this, and it will go asymptotically about x equal to 1. So basically, see here, try to understand f of x. If I erase this part, let me explain you once more so that it is very clear to you. Basically, what I have done is, see this black graph, which is the graph of y equal to f of x. So here it is below 1, and here it is x lesser than, this is the asymptote form, this one, x lesser than 1 by 2. Okay, now we have reversed this. Now range is lesser than 1 by 2, and domain is lesser than 1. Okay, so lesser than this, it won't touch the green line, and it will cross the black graph f of x at the line where it is crossing y equal to x, and it will go somewhere here like this. Now let me erase everything so that it's pretty much clear. Okay, so it will look something sort of this. And let me redraw this line of mirror, which is y equal to x. So this purple line, let me redraw this. It will cross here, and it will go something sort of this. Okay, so this is the graph of f inverse. I hope you understood this. Okay, so what is the first step? Draw the y equal to x line, and then domain will become range, and range will become domain. Got it? Perfect. Now they're asking the third one to find the inverse and state the domain of f inverse. So just now domain we have figured out. So let me quickly write it down here. Domain of f inverse of x is the range of f of x. And what was the range of f of x? Range was lesser than 1. So that will be x lesser than 1. Okay. So this is the domain for f inverse of x. X lesser than 1. Now I need to find the expression for f inverse of x. So let's quickly see this expression. It is 2x plus 1 over 2x minus 1 f of x. So assume y is equal to 2x plus 1 over 2x minus 1. Now we interchange the variables x and y and make y as a subject. Okay, so you just cross multiply 2y minus 1 times x is equal to 2y plus 1. So if you open the brackets, you get 2xy minus x is equal to 2y plus 1. Take the like terms to one side. So 2xy minus 2y equal to 1 plus x. Take y common. So you get 2x minus 2 equal to 1 plus x. All right. And therefore y is equal to 1 plus x over 2x minus 2. Got it? Now replace this with f inverse of x is equivalent to, you can say, this is minus only, right? Let me just quickly recheck. 2y minus x. Okay, perfect. So we get it as x plus 1 times 2x minus 1. Okay, so this is the answer. And we know the domain is lesser than 1 because that is the range of f of x. So this is what you have to follow. Whenever inverse is asked, always think of domain and range. The domain of f of x will become the range of f inverse of x and vice versa. The range of f of x will become the domain of x. And the line of mirror is what? Y equal to x. Always. Inverse exists about y equal to x. Okay. Because input will become output and output will become input. Now they're asking us the function g is defined by x 3x plus 2 for all x belongs to real numbers. Solve the equation f of x is equal to g f of 1 by 4. So this is composite function. So how do you solve this? Inside to outside. Inside to outside. Okay. So first we will compute what is g of f of 1 by 4, and here we have f of x equal to this. So what is f of 1 by 4? I need to compute this one. So what is f of x? So f of x was 2x plus 1 over 2x minus 1, if I'm not mistaken. Let's quickly check. 2x plus 1 over 2x minus 1, correct. So this is f of x. So in place of x, I'll plug in 1 by 4. So 2 times 1 by 4 plus 1 over 2 times 1 by 4 minus 1, right? And here we have f of x. So this becomes half plus 1 over half minus 1. And that's g of this equal to f of x. And now f of x is equal to g of this becomes 3 by 2 and this becomes negative 1 by 2. 2 and 2 cancels out. We get g of negative 3. That's x. Now what is g of x? G of x is 3x plus 2, right? So what will be g of minus 3? In place of x, you just plug in negative 3 plus 2. All right. So this becomes f of x, which is negative 9 plus 2. So we get f of x is equal to negative 7. Now I need to find the value of x. That is what they have asked. Solve the equation. Solve the equation means get the value of x. Therefore, we get f of x is equal to negative 7. Now don't do this. 2x plus 1 over 2x minus 1 equal to negative 7 and then solve for x. Instead, what you can do is, so I'm doing it over here. Let me change the color. Instead, you got f of x is equal to negative 7. Now, don't equate the function to negative 7. Again, kill the time. Okay, so directly what you can do is you can take the inverse. Therefore, x is equal to f inverse of negative 7, which is much easier as compared to the traditional method of solving. So what is f inverse? F inverse we have already found in the previous part. So although it is for just 3 marks, isn't it? So f inverse of 7 would be x is equal to, in place of x, negative 7 plus 1. You just plug in over here, right? Negative 7 over 2 times x minus 1. So x is negative 7 minus 1. So you get x is negative 6, 2 times negative 8. So you get x is equal to negative 6 over negative 16, which is nothing but negative and negative cancels out. With 2, we can cancel 3 over 8. So that's your answer. Okay. 3 over 8 is the correct answer. I hope you understood the logic and the concept over here. Okay. Now, coming on to the sixth one, belongs to trigonometry and radian measures. So it says the diagram shows a metal plate OAB CDEF consisting of sectors of 2 circles, each with center O. Okay, so center is given to us and it's consisting of 2 sectors. All right. Angle AOB is equal to angle EOF, which is theta radians, and angle COD is equal to 2 theta radians. Okay, 2 theta radians. Now we are given that, and the radius of the sector COD is 2r. That is also given. The radii of sectors AOB and EOF are r centimeters. So let me highlight the given information. Now it says it is given that the perimeter of the plate is 14 centimeters and the area of the plate is 10 centimeters square. All right, so we are given that r is greater than 3 by 2. So these conditions we have to be very careful and keep in mind. Find the values of r and theta. Okay, so this is what I need to find. So let's quickly get into this. Let's see how to find the perimeter, right? So perimeter is basically this OF, right? OF plus EF plus ED plus arc CD. Let me mention arc here. EF is also an arc plus BC line plus AB arc. So there are 3 arcs plus OA, right? Okay, so this much we have. Right, so complete C from here to here. OC is how much? OC radius of COD. Okay, that's 2r. So can I say B to C, this distance will also be r? Because OB is actually equal to r, right? OC is 2r, so this will be r. Similarly, this distance will also be r. Getting it? So first equation we will get from this given piece of information of perimeter. So perimeter is equal to r plus r. These 2 r's are done. Okay. And then these 2 r's. So we get plus 2 extra r's plus now three arcs are there. Okay, AB. How do I compute arc AB? Arc AB will be equal to L equal to R theta. So that's your AB. So I'll write R theta. This angle is theta. Similarly, one more R theta, which is EF, L equal to R theta. Radius is R, angle is theta. So EF is also done. Now I need to compute CD. So CD will be how much? The radius is 2R. So L is equal to 2R and the theta is also 2 theta, isn't it? So multiplied by 2 theta. So this becomes 4R theta. So let me add this as 4R theta. Now if I'll quickly add this up, I'll get 4R plus 6R theta and this is equal to 14. Okay, so I can simplify this and cancel out the common 2. So this becomes 2R, dividing the entire equation by 2. So this becomes 3R theta. Okay, so that's my equation 1. Okay, now we need to use the area of this. Now for area, what are the areas we have? Area, let me use a different color. Area of this smaller sector, area of this. So what is the area of this one? It's half R square theta. Area of this one is also half R square theta because radius is R and theta is angle. Now area for this would be half. R is what? R is 2R basically. The radius 2R square and theta is 2 theta. Okay. So now I'll write it down. Half R square theta plus half R square theta plus half 2R whole square times 2 theta. Got it? So now what is area given to us? That's 10 centimeter square. So I'll write 10 here. Half R square plus half R square will become R square theta plus 2R square completely gives you 4R square times 2 theta over 2. 2 and 2 cancels out. We finally get R square theta plus 4R square theta, which is 5R square theta equal to 10. And that is my second equation. Now I see that both the equations are in terms of R and theta. Okay, so I can solve for two variables with these two equations. So I can simply say therefore theta becomes 10 by 5 over R square, which is nothing but 2 over R square. Okay, so that is the value of theta over here. Now I'll substitute this value in equation 1. Put this in equation 1. And therefore what I'll get 7 is equal to 2R plus 3R. Theta is 2 over R square, right? So I've replaced theta by 2R square. So R and square will cancels out. So we take 7 equal to 2R plus 6R. Okay. This is, no, sorry. Slight mistake I've done. That's 6 over R, isn't it? So this R and R square cancels out. Okay. Now further simplifying, multiply throughout by R. So we'll get 7R is equal to 2R squared plus 6. So rearranging this, I'll get 2R squared minus 7R plus 6 equal to 0. Now 2 times 6 is 12R squared. Factors are 4R and 3R with a negative sign. So I can quickly factorize this. Minus 4R minus 3R plus 6 equal to 0. You can use your calculator to solve this quadratic equation. So now 2R, if I take common, I'll get R minus 2. And then R minus 2 multiplied by negative 3 equal to 0. So what I get from here is 2R minus 3 and I get R minus 2 equal to 0. So R is equal to 3 over 2 or R is equal to 2. Now let's see the condition for R, what was given to us over here. So R should be greater than 3 by 2, which is greater than 1.5, right? So equal to 3 by 2, I can neglect this value. So my answer is R equal to 2. Okay, because since R is greater than 3 by 2, so I cannot take the value equal to 3 by 2. Now, what is theta? Theta is basically 2 over R squared. Therefore, theta is equal to 2 over R squared. So 3 by 2 whole squared, which becomes 2 by 9 over 4, which is nothing but 8 over 9. Getting it? So this is what the theta is. Now, if you want, Mm, Let me quickly check whether. One second, one second. I think I did a mistake. R is equal to 2, right? My bad, sorry. By mistake, I've taken it as 3 by 2. Okay. So theta was 2 over r square. I'm so sorry. By mistake, I had taken this. So r is equal to 2 we got. Therefore, 2 over 2 squared, which is equal to 2 over 4. And therefore, theta is equal to 1 by 2 or 0.5. So that is your answer. Okay, now let's check whether it is correct or not. So theta should be less than 3 by 4. So 3 by 4 in decimals is how much? Since theta is lesser than 3 by 4. So 3 by 4 is 0.75. So 0.5 is lesser than 0.5 is lesser than 0.75. So it makes sense. Okay, so these are the solutions. Now moving on to the next one, the seventh question. So here it says, by expressing the quadratic equation in the form negative, basically completing the square in the form negative a times x minus b whole square plus c, where a, b, and c are positive integers. Find the coordinates of the vertex of the graph with equation y equal to this. Okay. Now let me explain you how to do completing the square. See, we can write x plus a whole squared is equal to x squared plus 2ax plus a squared, isn't it? So now I can rewrite this thing as x plus 2ax is equal to x plus a whole squared minus a squared. Just taking a squared to the left hand side, right? So whenever we have this kind of expression, okay, whenever we have this kind of expression, I can write it as, see here, whenever you have 2a, right? When the coefficient of x is 2a, half of it will come inside the square minus this a squared. Okay, so what I'm trying to say here is, see here, 2x squared plus 8x plus 11, right? Now, whenever you are doing completing the square method, make sure the coefficient of x square is positive. So you take and positive and it should be 1. So you take negative 2 outside as common, you'll get positive 8x over negative 2 plus 11 over negative 2. All right, next step. Negative 2 outside, you get x squared minus 8 over negative 2 gives you negative 4x minus 11 over 2. All right. Now, x squared minus 4x, isn't it in this form? This entire thing. So how I can write it as, this is x squared plus something, right? This is x squared minus. So I'll write x plus a square will become x minus 4 over 2, right? If it is 2a, then I'm taking it as a. So you divide the coefficient of x by 2. So 4 by 2 is 2. So this will become x minus 2 whole squared. And obviously this minus 2 outside. Okay, minus a squared. So what is a? A is negative 2, isn't it? So that will become 2 squared with a minus outside. I hope you're understanding this thing. So this squared is only for a and minus is outside. And the remaining negative 11 by 2, you write it as it is. Now expand this. X minus 2 whole square. This becomes minus um, 2 square, which is basically 4 minus 11 by 2. Okay. Now minus 2. So I'm solving it here further. Now take this 2 inside, so you'll get it as negative 2 multiplied by x minus 2 whole squared. Negative 2 times negative 8, negative 4 is positive 8. Negative 2 times negative 11 by 2 gives you positive 11, right? So this becomes negative 2 x minus 2 whole square plus 19. So that is the final answer. Now, what they have asked, find the coordinates of the vertex. So coordinates of the vertex is basically you keep x is equal to, when this term will be equal to 0. So when x is equal to 2, right? 2 minus 2 will become 0. And what will be the remaining constant? 19. So y is equal to 19. Okay, so this is called as the vertex form. This form of quadratic is only called as vertex form, where this is x minus b. X coordinate is called as b, and the c is called as the y coordinate of the vertex. So this is called as the vertex form. This, expansion, or you can say the completed square, actually represents the vertex form of the quadratic equation. Does that make sense? Otherwise, you could have used the formula itself. right? Which says x equal to minus b by 2a. This is the x coordinate of the vertex formula. Okay, so what's b? B is 8. So if you want to cross check, b is 8. So negative 8 over 2a. A is negative 2. Getting it? So how much are you getting? Negative 8 over negative 4, which is nothing but 2. And you were supposed to get 2 only. Got it? So you could have done this also. So for time being, let me erase this. Just for knowledge purpose, I'm telling you this thing. So this is another perspective of thinking. Okay. Next, coming on to the B part of it. Okay, belongs to integration, I think. We have to find the shaded area. It looks good. So we have y equal to negative 2x squared plus 8x plus 11, which is the parabola given, I mean the quadratic given to us opening downwards. And the line with the equation y equal to 8x plus 9. Find the area of the shaded region, right? So we know that here it is area between the curves, right? So whenever we have area between the curves, we have to use the concept of upper graph minus the lower graph. So this is the upper curve, area under the upper curve minus area under the lower curve. Okay, so the required area would be y upper minus y lower dx. Okay, because we have to consider the vertical strip with respect to x-axis. Now, how do I find the limits, right? A to B, lower limit and the upper limit. So I need to solve this. Okay, because these are the point of intersection. These are the points of intersection. Okay, so how do I get the point of intersection? Let's quickly solve it. So I have negative 2x. This is for point of intersection. Negative 2x squared plus 8x plus 11 is equal to 8x plus 9. 8x and 8x cancels out. I get negative 2x squared is equal to 9 minus 11. So negative 2x squared is equal to negative 2. Negative 2 and negative 2 cancels out. We get x squared equal to positive 1 or x is equal to plus 1 and minus 1. Okay. So obviously negative 1 will be this, right? That's x equal to negative 1. And this is x is equal to positive 1. So we got the upper limit and the lower limit as this. So area is minus 1 to 1. Upper graph is negative 2x squared plus 8x plus 11 minus the line, which is 8x plus 9. And this entire thing I need to integrate with respect to dx. So let's see if we could cancel out the common terms. So area required will be negative 1 to 1. So 8x and 8x I can cancel out. So the integrand would be negative 2x squared plus 11 minus 9, right, with respect to dx. So I think this can be further simplified to negative 1 to 1, which is negative 2x squared plus 2. I need to integrate this with respect to dx. So this becomes negative 1 to 1, negative 2x 2 plus 1 over 2 plus 1 plus 2x. Okay, under the limits, this negative 1 to 1. So we get the final thing under the limits minus 1 to 1, or negative 2 over 3 x to the power 3 plus 2x under the limits 1 and minus 1. So we plug in the limits, upper limit, which is negative 2 over 3, 1 cubed plus 2 minus the lower limit, negative 2 over 3 minus 1 to the power 3, 2 times negative 1, which is minus 2. Solving it further, we get a equal to negative 2 over 3 plus 2. Now, negative times negative becomes positive. So that's positive 2 over 3. All right. And then negative times negative becomes positive. So this becomes positive 2. Okay. So, or let's take it as negative here. And then later on we'll expand this. So that's negative 2. So if I'll open the brackets, I get negative 2 over 3 plus 2 minus 2 over 3 and then plus 2. So we get negative 2 over 3, negative 2 over 3 gives you negative 4 over 3 plus 2 is 4 and therefore A equal to, if I take the LCM, negative 4 plus 4 times 3 is 12 over 3 and therefore A equal to 8 over 3 square units obviously. That's your answer. So you could do using the calculator as well, right? You can plug in this integrand in the calculator and the limits as -1 to 1. So you don't have to worry about this. But do mention the integration, right? Because you'll be judged on whether you know the concept of integration or not. So do write this step, and then later on you can use the calculator so that you can avoid these many steps. Okay, fine. Now moving on to the next question, which is from circles. So let's see the question 8. It says the equation of a circle is x square plus y square plus px plus 2y plus q equal to 0, where q and p are the constants. Perfect. Express the equation in the form x minus a whole squared y minus b whole squared equal to r square, which is the standard form of a circle, standard equation of a circle, where a is to be given in terms of p and r square is to be given in terms of p and q, right? So a is to be given in terms of p. All right. Okay, perfect. Now we'll do completing the square here. So let me write it down. X squared plus, let me write the like terms together. Px plus y squared plus 2y plus constant q equal to 0, right? Now applying the concept of completing the square for x squared plus px. So how I can write it as x plus p by 2, I told you, right? X plus a by 2. Whatever is the coefficient of x, you divide by 2. This becomes whole square minus p by 2 whole square. This is how we complete the square. Now, y square plus 2y. So this will become y plus 2 by 2 is 1. So y plus 1 whole square minus, okay, minus, always remember minus 1 square plus q is equal to 0. Okay, so this becomes x plus p by 2 whole square minus p square by 4 plus y minus 1 whole square minus 1 plus q equal to 0. So rearranging this in terms of this equation, we get finally x plus p by 2 whole square plus y minus 1 whole square is equal. Taking all the constants to right hand side, so we get 1 minus q plus p squared by 4. Okay. Now comparing it with this equation of the circle, which is x minus a whole square plus y minus b whole square equal to r square. So a is with x minus this. So interpretation, therefore a equal to x minus of minus p by 2, right? So a is negative p by 2, right? Here x a is what? X minus a, right? So I can write it as minus of minus. That becomes plus. So a is p negative of p over 2. And what is the radius? R square value is, complete this thing. That's my r square. So 1 minus q plus only, right? Yeah. P squared by 4. Okay. So that is the answer for this one. Now, moving on to the next, which is basically equation of a normal. Okay, perfect. So now it says the line with equation x plus 2y equal to 10 is the tangent to the circle at A, 4, 3, and this is the equation of the tangent at the circle at this particular point it is given to us. All right. So therefore, I have to find the equation of the normal at the point A. Now, let me rewrite the equation of tangent. So equation of tangent, what is given to us? 2y is equal to negative x plus 10. Right? Therefore, y is equal to negative 1 by 2 times x plus 10 by 2 becomes 5. Okay. So now what is the slope of the tangent? It's negative 1 by 2. So what will be the gradient? Or yeah, the gradient or the slope of the normal. So gradient of the normal would be negative 1 over negative reciprocal of this tangent, right? Which becomes 2. Right? So I know the slope of the normal and I know the point which is on the normal, right? Therefore, equation of normal becomes easy to find now, which will be in the form of a line, which is y equal to mx plus c. And the point is 4, 3, and the slope is 2, right? So it becomes y equal to 2x plus c, and 4 comma 3 also passes through it. So 2 times 4 plus c So this becomes 3 equal to 8 plus c, or 3 minus 8 equal to c, or c is equal to -5, right? And therefore the equation of the normal is y equal to 2x minus 5. That is the answer. I hope it is clear to you. Okay, y equal to 2x minus. Now they're asking us to find the values of p and q. Okay, so let's see how we can find the values of these two. Okay, it's for 5 mark. All right, so it is given that this is a tangent, right? So what I can do is I can quickly differentiate this function. Okay, so understand the concept. I know the derivative, right? dy by dx. Let me first write this. X square plus y square plus px. So what and all we have? We have x square plus y square plus px plus 2y plus q is equal to 0, right? So we have this equation of the circle, which is given to us in this fashion, and plus q equal to 0. And we know that the tangent is also there at a. So equation of the tangent is x plus 2y equal to tangent is x plus 2y is equal to 10 at the point 4 comma 3, right? Now when I differentiate this equation of the curve, let's say if I differentiate with respect to x, differentiate with respect to x. Okay, so what will I get? It's a circle basically, right? Okay, so it's a circle, so we can find the value of p and q. That we can do. And do I know the centers as well? Okay, we don't know, right? P by 2. Okay, all right. Let me use a different approach. So let me first explain you what is this differentiation will help out. Okay, there are two methods. So let me solve by both the methods so that it will be clear to you. Now what I need to do is differentiate with respect to x. Okay, so this will become 2x. Using chain rule, y square derivative is 2y dy by dx. Px derivative, p is a constant. 2y derivative is 2 dy by dx, because y is the function in x. Q derivative is 0, so equal to 0. Okay, now what we have over here is, so this dy by dx, if I want to find, I can say 2y plus 2 dy by dx plus 2x plus p, right, equal to 0. Now from here I got y equal to -1 by 2x plus 5. Okay, this is the equation of the tangent. So dy by dx of the curve gives you what? The slope of the tangent, right? The dy by dx, basically this dy by dx, which is nothing but negative of 2x plus p, right? The slope of the tangent, 2y plus 2. This thing is basically equal to the slope of the tangent, isn't it? Which we know, this is the slope of the gradient. I mean the tangent, isn't it? So dy by dx, when we differentiate the curve itself, what do we get? We get the function itself, the slope at that particular point. So this is at a, dy by dx at a, which is 4 comma 3. So what is dy by dx at 4 comma 3? So x is 4 and y is 3. So you just plug in x as 4 plus p over 2y. So 2 times 3 plus 2, which is equal to -1 by 2. Okay, so we get 8 plus p over 8 is equal to 1 by 2. Negative and negative cancels out. So therefore I get 8 plus p is equal to 4, or p equal to -4. Got it? So I got the value of p. Now, once I have the value of p, I need to compute the value of what? I need to compute the value of q. So now this point, so it's a circle, right? So try to visualize this. It's a circle. It's a circle. And this is the center as negative p by 2, comma 1. Okay, and there is a point A. This is point A. And the tangent what we have is y equal to -1 by 2x plus c. So I'm drawing a rough sketch of it. Okay, so this point A will satisfy the equation of the circle as well as the equation of this tangent also, isn't it? So now you have the value of P, you have the value of X and Y. So put this value in circle equation, which is the initial equation of this. So x squared plus y squared, I'm doing it here, x squared plus y squared plus px plus 2y plus q equal to 0, right? Now what is x? X is 4, y is 3, p is -4, x is +4, y is 3, and I need to find the value of q equal to 0. So we get this as 16 plus 9 minus 16 plus 6 plus q equal to 0. 16 and 16 cancels out. 9 plus 6 is +15 plus q equal to 0, or we get q equal to -15. Got it? So this is one approach by differentiating the function itself, so that dy by dx is the slope of the tangent, and the slope of the tangent we know, just equating it, we get the value of at that particular point A. Right. Now, what could be the second approach? Understand that. Okay. So we have found a normal, isn't it? Normal means what? Let me write here. Do we have space? Okay, no worries. So method 2. So let's say this is the circle what we got, and here it is point A, which is 4, 3. We got the equation of the normal as well. Normal means 90 degrees. And in IGCSE, we have learned circle theorems, isn't it? So this is y equal to -x over 2 plus 5. And we got the equation of the normal as this equation as y equal to how much? 2x minus 5, right? So we got it as 2x minus 5. So a line, this is basically a tangent, right? So it's a tangent. So we know that radius and tangents are perpendicular. The radius is perpendicular to the tangent in a circle using circle theorem, isn't it? So radius will obviously pass through the center. So can I say the radius equation is same as the equation of the normal itself? So you could have used this also. Now what is the center? Center is -p/2, 1. So this point will satisfy the equation. The center lies on normal. Why I can say so? It lies on the normal. That is because it's a radius. The equation of the radius will also be the equation of the normal. And therefore, I can say -p/2, 1. It satisfies the equation of normal, which is y equal to 2x minus 5. So y is 1, 2 times -p/2 minus 5. So 2 and 2 cancels out. Now, what do we get? We get 1. Is it 2x minus 5? Let me just quickly check. What is the equation of the center? 2x minus 5, right? Yeah, makes sense. 2x minus 5. So minus p/2 and y is 1. Okay, makes sense. All right. So here we have -p/2 and this is this. So we get 1 minus p minus 5, right? So p value is actually how much? -4 we are getting. So y is 1, right? Y is equal to 1. Perfect. So we're getting y as 1, and it makes sense also. Okay, so you could have used this. So from here, p value you can calculate, and then you can calculate the q value as well. Okay, because q is lying on this circle itself. All right. Once you know p value and you know that 4, 3 lies on the circle, then you can find the q value. So these are the two concepts which you can apply. Okay. So I thought of sharing it. So you could have used this theorem as well. So there are more than 2 approaches for a simple question. Okay, so using differentiation also you can use, and you can use the circle theorem. So I would say always think of circle theorem, the calculation becomes easy and the concept also becomes easy. Otherwise, differentiation also you could use. Okay, now coming on to the next. ninth question. So let's quickly read this one. We have y equal to some quadratic equation, k squared by 2x squared minus 2kx plus 2. And the equation of a line is y equal to kx plus p, where k and p are constants. Okay, we have this equation. And the curve, and it is given that k lies between 0 to 1. And first question says it is given that one of the points of intersection of the curve and the line has the coordinates 5 by 2 comma 1. One of the point of intersection is given. Find the values of k and p and find the coordinates of the other point of intersection. Okay, so we have to do this. All right, now let's proceed. It is given that this is the point of intersection, right? Point of intersection means what? It will satisfy the equation of both the curves, this as well as this. Okay, so using the concept of point of intersection, which is common to both the curves. So I know that the point is 5 by 2, this is x value, and 1 by 2 is y value. So just plug in this in this equation, y equal to k square over 2x squared minus 2kx plus 2. Okay, so y value is 1 by 2. So k squared by 2, and this becomes 5 by 2 whole squared minus 2k 5 by 2 plus 2. Simplifying this further, we get k squared times 25 by 8 minus 5k plus 2. Okay, this is what we will get, right? So now multiplying throughout by, okay, so basically I can write it as 25 by 8 k squared minus 5k plus 2 minus 1 by 2, taking the constant to the right hand side equal to 0. So this is a quadratic in terms of k. If I multiply throughout by 8, multiply by 8, so I'll get 25k squared minus 8 times 5 is 40, 2 times 8 is 16, and 8 times negative 1 by 2 is negative 4 equal to 0. So what I get is 25k squared minus 40k plus 12 equal to 0. Okay. So now I need to solve for k, therefore k equal to, using the formula, you can use a calculator, negative b plus minus under root b squared, so 40 squared minus 4ac, so 4ac divided by 2a. So I get the value of k as 40 plus minus under root. 40 square is 1600 minus 25 times 4 is 100. 100 times 12 is 1200 over 100. So we get this as 40 plus minus under root 400 over 100, which is nothing but 40 plus minus 20 over 100. Okay, so I get two values of k, which is 60 over 100, and we get k equal to 20 over 100. Okay, so from here I get 3 by 5, and from here I get k as 1 over 5. Now what is given to us? It's given that k lies between 0 to 1, isn't it? So we get two values of k from here, which is 3 by 5 and 1 by 5. Okay, all right. So now corresponding to these k values, I need to find 60. Oh, just a moment. Okay. I've done a silly mistake here. That's not 100, that's 25, right? Okay, so this is 2 times 25. I made a small mistake here. So you can write k equal to positive 40 plus minus 20 over 25 times 2 is 50. Getting it? So you get k is equal to 60 over 50, and you get k is equal to 20 over 50, isn't it? So clearly this becomes k equal to 6 by 5, and we get k equal to 2 by 5. Now it's given that since k lies between 0 to 1, and therefore k is equal to 2 by 5 is my answer. Got it? My mistake here, divided by 2a, I did 50. This was 2 times 25. Okay. So k, its range is 0 to 1. So that's how we have to do this. Okay, fine. So we got the value of this. Now I need to find the value of p. So I'll plug in the value of k in the equation of the line to get the value of p. So what I need to do here is we have y is equal to kx plus p, and the point what we have is 5 by 2 and 1 by 2, which is a point of intersection. Okay, so we got this 1 by 2. Now y is 1 by 2, k is 2 by 5, x is 5 by 2 plus p, and therefore 1 by 2 is equal to 2 and 2, 5 and 5 cancels out, plus 1 plus p. And from here I can say p is equal to 1 by 2 minus 1, which is negative half. So we got the value of p as negative half. All right. So we got k as 2 by 5 and we got p as negative 1 by 2. Okay, makes sense. Now, what is the next part of the question? It asks us to find the coordinates of the other point of intersection. Okay, so once we know the value of k and thus k and p, so again, point of intersection means just equate these two. Okay, so let's write them down over here. So we got y is equal to k squared by 2, x squared minus 2kx plus 2. And the y equation for the line is kx plus p. So we just need to equate them to get the other values of intersection, right? So y equal to kx plus p and k square over 2x square minus 2kx plus 2. So point of intersection, we just equate them. So k value is 5 by 2 by 5. So 2 by 5 whole square, 1 by 2 is already there, minus 2 times 2 by 5, x is 5 by 2, isn't it? Or no, I don't need x value here. And I just need to multiply by x because I need to find the other value of x, right? So just k value I'll substitute here, minus 2, k is 2/5, x plus 2 equated to kx plus p. So k is 2 by 5, all right? X minus p is 1 by 2. Now I'll get a quadratic equation. So solving it further, I get 4 divided by 2 times 25 x squared. This becomes negative 4 by 5x plus 2 is equal to 2 by 5x minus 1 by 2. So we get here 2 by 25 x squared minus 4 by 5 times x plus 2 is equal to 2 by 5x minus 1 by 2. So taking everything to one side, we get 2 by 25 x squared, all right, minus 4 by 5 x minus 2 by 5 x plus 2 plus 1 by 2 equal to 0. So I'm solving it here. So we get 2/5 of 2 over 25 x squared, okay, minus 6 by 5 x plus 5 by 2 equal to 0. Now multiplying throughout by 25, right? Multiplying throughout by 25, what will I get? I'll get 2x squared minus 25 over 5 is 5. 5 times 6 is 30x plus 25 times 5 is 125 over 2 equal to 0. Now multiplying throughout by 2, I'll get to remove this 1 by 2. So 4x squared minus 2 times 30 is 60 plus 125 equal to 0. Getting it? So now when I solve this for x, I'll basically get, 125. So using the formula 60 plus minus under root 60 square is 3600 minus 4ac. So 4, 4 and 125 over 2. So 2 times 4. So we get the value of x as 60 plus minus under root 3600 minus 4 times 125. 125 into 2 is 500. So these values you will get. So you can plug in the equation itself. So basically you will get Let me just quickly do this. Okay, so if you put this in the calculator, I'm doing it in the calculator. From here, you'll get x is equal to the other value. Obviously, one value will be 5 by 2 and 1 by 2. Another value you're getting x as 25 by 2. Okay. Once you get x as 25 by 2, you need to find the y value. So y is equal to, put it in the equation of px, right? Y equal to k value was how much? K was 2 by 5, right? So 2 by 5 x minus 1 by 2. So we got x as 25 by 2. So let me put this here. And into 25 by 2 minus 2. So we get 5, 2 and 2 cancels out. 5 minus 1 by 2, which is 9 by 2. Okay, so these are the other coordinates. So let me quickly explain what we have to do. Once we found that the point of intersection, so this point of intersection will satisfy both the equations. So first I have plugged in this point in the equation of this quadratic function. All right, which will make sure that, there is only one unknown, k. So I know x and y value, I get a quadratic in terms of k. So we found what is k value. Once I know k, I have plugged in the second equation, and I know the point is 5 by 2 and 1 by 2. So we got the value of p. Now substitute the value of k in both the equations. So let me use a different color here. In this equation of the curve and the equation of line. And to get the other point of intersection, you just equate them. So here we have equated to get the second point of intersection. Are you getting this? Now, once we solve this, we basically get x equal to 5 by 2, which was already there. And the second point of intersection is this. Now, x is 25 by 2. To get the y value, you put it in the equation of y equal to kx plus p. So k was 2/5 of x and p was negative 1 by 2. So we get the second point. Okay. Now, coming on to the b part, it says it is given that instead of instead that the line and the curve do not intersect. Okay, so what is the condition for do not intersect? So let's say if the parabola is something like this and the line is something sort of this, right? So that means they are not intersecting. That means discriminant is lesser than 0. This is the condition. If there is only one point of intersection of a line and a quadratic, then discriminant will be equal to 0. That is b square minus 4ac. And if it crosses us at 2 points, then discriminant will be greater than 0. So our case is the first one. Okay, so discriminant will be lesser than 0. Okay, so now we know that k is equal to 2/5. So I'll just plug in the value of k in the equation. So which is 1 by 2, equation of the curve, k squared. So k is 2 by 5 whole squared, x squared minus 2kx, k is 2/5 x plus 2 is equal to the y equation, which is kx plus p. So 2 by 5x plus p, right? Now I'll arrange it out. I'll get 4 by 25 and then 2 here, x squared minus 4 by 5x plus 2 is equal to 2/5 of x plus p. Quickly rearranging this, I get 2 over 25 x squared minus 4x by 5 minus 2x by 5 plus 2 equal to p. Or I can actually take p also, it's a constant, minus p equal to 0, making it a quadratic equation. Therefore, again, I'll get 2 over 25 x squared minus 6x over 5 plus 2 minus p equal to 0. Okay, now multiplying throughout by 25, multiply by 25 to remove this 25. So we get 2x squared minus 30x. 25 into 1 by 5 is 5. 5 times 6 is 30 plus 25 times 2 minus p as whole equal to 0. Now discriminant condition is lesser than 0 because they have mentioned here do not intersect, right? Find the set of possible values of p. So this is the condition for not intersecting. Okay, remember this. Discriminant should be lesser than 0. So b square minus 4ac. So b square is this minus 4ac. 25 times 2 minus p is lesser than 0. So this is 900. This becomes minus 8. 8 times 25 is basically 200, isn't it? Times 2 minus p is lesser than 0. If I open this, 900 minus 400 plus 200p is lesser than 0. And therefore, I can say 200p is lesser than negative 500, or p is lesser than negative 500 by 200, which is negative 5 by 2. So that is the set of possible values of p. Okay, I hope it is clear to you. So p should be lesser than negative 5 by 2. Now, coming on to the next question, the last question for this paper. So let's quickly read this. It says the function f with domain x greater than 0, very, very important point, is such that f dash of x is equal to this. It is given that the curve with the equation y equal to f of x passes through the point 1 comma 0. So this is given to us. Find the equation of the normal to the curve at 1 comma 0. Okay, so let's try to do this. So first, this f dash of x represents as what? It gives you the gradient of the tangent, right? The slope of tangent, basically. The slope of tangent. This is the gradient function. So at x equal to 1. So let's find what is f dash of 1. So 8 times 2 times 1 minus 3, whole thing to the power 1/3, minus 10 times 1 to the power 2/3, right? So this becomes 8. 2 minus 1 is 2 minus 3 is negative 1 to the power 1/3. Getting it? Which is nothing but minus 10, right? So 1 to any power is 1 itself. Make sense? F dash of negative 1, I mean, this is f dash of x. So f dash of 1, we are getting it as this. So negative 1 to odd power, right? So what is this 1/3? 2 minus 1/3 we are getting, right? So basically, how much we are getting this thing? This gives us 1 over negative 8. It should give, yeah, negative 1 to the power of 1/3, isn't it? If you differentiate. So negative 1 to odd power, the cube root of it, basically. What is the cube root of negative 1? So negative 1 times negative 1 times negative 1. That is negative 1 only. So this becomes negative 8 and then negative 10, right? So what is f dash of 1? That gives you negative 18. So what is the slope of normal? Slope of normal would be, okay, so cube root, remember this, cube root of negative 1 is negative 1 itself, isn't it? So this is what we have discussed here. So the slope of the tangent is negative 18. So slope of normal will be what? It would be positive 1 over 18. Negative reciprocal of the slope of tangent. Okay. Now we know the slope and we know the point as 1 comma 0. Therefore, equation is y equal to mx plus c. Let me quickly erase this bit. And let me write it over here. So the equation is y equal to mx plus c. Okay. So slope is 1 over 18, x plus c. And when x is 0, y is 1. 18 times 0 plus c. Therefore, c is equal to 1. Therefore, equation is y equal to x over 18 plus 1. Got it? Or is it other way around? X is 1. Okay, okay, okay. It's other way around. My bad, sorry. So y is 0, right? Y is 0, x is 1. So that's 1 over 18, 1 plus c. So c is negative 1 by 18. Correct. So therefore, what is y? Y equal to 1 over 18x negative 1 over 18. That is the equation of the normal. Okay. It is x is 1, y is 0. Okay. Correct. So that is the equation of the normal over here. Now I need to find the value of f of x, right? So derivative is given. So that means I need to integrate f dash of x with respect to dx, both the sides. So 2x minus 3, whole thing to the power 1/3 minus 10x 2/3 with respect to dx. Okay. When I integrate this, this will become f of x 8 is the constant as it is. Function 2x minus 3 as it is. Power, you increase the power by 1. Okay. And do the same thing in the denominator. Plus 1 minus 10 as it is constant. X to the power 2/3 plus 1 over 2/3 plus 1. Since it is indefinite integral, so plus c. Right? So we get f of x is equal to 1 by 3 plus 1 is 4 by 3. So 3 goes up, 4 remains down, multiplied by 8. We get 2x minus 3 to the power 4/3. And do remember to, write the coefficient of x in the denominator. So divided by the coefficient of x in the denominator. All right, so first you integrate the powers and then put the derivative of the function in the denominator. So derivative of 2x minus 3 is what? 2. So put it in the denominator. Negative. So 2/3 plus 1 is basically 5/3. So 3 goes up, multiplied by 10 over 5, x to the power 5 over 3 plus c. So this becomes 3. 4 and 2 and 8 cancels out, times 2x minus 3 to the power 4/3 minus 6. 5 times 1, 5 times 2, x to the power 5/3 plus c. And now I need to find the value of c. So we are given that the point, right, passes through the point 1 comma 0. That means the point is 1 comma 0. So x is 1, y is 0. So that means, how do I read this? F of 1 is equal to 0, right? So that is 0. And we plug in 1 here. 2 times 1 minus 3, whole thing to the power 4/3 minus 6 times 1 to the power 5/3 plus c. Now this becomes 0. This becomes 3 minus 1 to the power 4/3 minus 6. 1 to any power is 1 plus c. Now negative 1 to the power 1/3 is negative 1, and then to the power 4 will become positive. So becomes 3 minus 6 plus c equal to 0, or negative 3 plus c equal to 0, or c equal to 3. Right? So final answer, f of x is equal to 3 times 2x minus 3, whole thing to the power 4/3 minus 6x to the power 5/3 plus 3. Okay, substitute the value of c here. So this is the final answer. Now, next, C bit, this is the last part of the question. It is given that the equation f dash of x equal to 0 can be expressed in this form. Okay, equal to 0. Determine, making your reasoning clear, whether f is an increasing function, a decreasing function, or neither. Okay, so what we do over here is, let's quickly see what is f dash of x equal to 0. So f dash of x is equal to 0 is 8 times 2x minus 3 whole thing to the power 1/3. Okay, and then minus 10x to the power 2 over 3 is equal to 0. That is what is given to us here. Okay, now I need to find the turning points, right? How do you check whether a function is increasing or decreasing? Either f dash of x is greater than 0 for increasing, okay, and for decreasing, f dash of x should be lesser than 0. So we have to find the turning points, right, by equating it to 0, and then we put it on the number line, right, after finding the turning point. Then only we can find the inequality. Now when I solve this, basically 2x minus 3 to the power 1/3 is equal to 10 times x to the power 2/3. Okay, now cubing both the side, cube both sides, what do we get? 8 cube is 512. 2x minus 3. If I cube this, 1/3 whole thing to the power 3, and then 10 cube is 1000, x to the power 2/3 whole cube, right? So this will become 512, 2x minus 3, 1/3 and power 3. Power to power gets multiplied, so that becomes 1, equal to 1000. This becomes x squared. 2/3 times 3 is basically 2, right? Now, if I solve this, I'll get 1024x minus 631536, and this is 1000 x squared. Now, transposing everything to right hand side, I get 1000 x squared minus 1024x plus 1536 equal to 0. So if I take 4 common, right, or let's take 2 common, so this becomes 500x squared minus 512x plus 7 times 2 is 14. This becomes 6, 768 equal to 0. Again, taking 2 common, this becomes 2 minus 256x plus 2 threes are then 8, 384 equal to 0. Again, if I take 2 common, I'll get 125 minus 128x plus 192 equal to 0. Right? So basically, this is what is given to us. Okay, now I need to solve this. Now clearly I can say the discriminant, right? Discriminant, let's check, which is basically b square minus 4ac. Okay, so negative 128 whole square minus 4ac. Okay, so if I check this value, basically, how much are we getting? Let me quickly try this in the calculator. So in fact, this value was turning out to be negative 79616, right? So my discriminant is basically negative. So if discriminant is lesser than negative, that means there is no solution. I don't have any turning points, right? There are no turning points. So I cannot find the range in which it is increasing or decreasing. I cannot do that, right? So what we have to do is we have to do trial and error method with the points given to us in this case. Trial and error, because I cannot find the turning point, so I cannot find the range of values of x for which it is true. Okay, so using trial and error, what we can do is there are certain points given to us. Let's check what happens to the gradient, right? Or f of x. F dash of x, where do we have? This is my f dash of x, right? Let me use a different color. This is your f dash of x. So let me quickly write here. F dash of x is basically 8 times how much it is 2x minus 3 to the power 1/3 minus 10x to the power 2/3. Okay, so basically if I'll check for 0, right, any negative value, so if I check for 1, let's say, if I check for negative, so f dash of 0, right, f dash of 0 would be 2 times 0 is 0, negative 3 cube root minus 10 times 0 to this, isn't it? So negative 3 to the power cube root of this, right? So this is basically negative only, right? So that's some negative value. And if I check for, f dash of 1, what will I get? So when x is increasing, basically, so this becomes, so that's negative only, right? This is basically lesser than 0. And if I put x equal to 1, so I'll get basically negative 1 to 1/3, 10, 1 to 2/3. Okay, so this becomes negative 8 and this becomes negative 10, right? So negative 3. So this is basically decreasing only, right? In fact, let me just check the value of negative 3 whole thing to the power of cubed. This is actually negative 1.44 and this is negative 18. Right, so which is decreasing basically, right? When x is increasing here, when x is increasing from 0 to 1, what is the gradient? F dash of x is actually decreasing, right? So when x is increasing, f dash of x is basically decreasing. So this is a decreasing function. Therefore, I can conclude by trial and error, it's a decreasing function. Okay, so this is an important question where you won't be able to find the turning point because you know the discriminant is lesser than 0. And this is how you have to do using a trial and error method. Okay, so I hope students you learn something new. And if you want to support me, you can do this by sharing with your friends and do subscribe my channel. Thanks for watching.